Greetings, I'm Moon.
Hi, I'm Peace.
Hi, I'm Rushdina.
Hi, I'm Iza.
Hi, I'm Nicholas.
Hi, I'm Aisa. I'm Pia. I'm I.
Hi, I'm Ashik.
Green technology is a term often heard nowadays to refer to the progression of technology compared to their 20th century counterparts. However, what is green energy? Well, for a start, the definition of technology is the methods, systems, and devices which are the result of scientific knowledge being used for practical purposes, while green in this context refers to harming the environment as little as possible. Hence, green technology is technology intended to mitigate or reverse the effects of human activity on the environment. Related to this would be green energy, which should not be confused with renewable energy or clean energy. Green energy is any energy type that is generated from natural resources, such as sunlight, wind, or water, while clean energy are the types which do not release pollutants into the air. Meanwhile, renewable energy comes from sources that are constantly being replenished. As an example, biomass energy is green and renewable, but not clean. Nuclear energy is green and clean, but not renewable, while wind energy is green, clean, and renewable.
Wind energy is the form of energy conversion in which turbines converts the kinetic energy of wind into mechanical or electrical energy that can be used for power. This is done via the implementation of wind turbines, which generates electricity when gushing wind spins the blade of the turbine. Historically, wind power has been used for centuries for such tasks as grinding grain and pumping water by using a windmill, the historic ancestor of the wind turbine. A windmill harnesses the wind to turn a millstone to great grains of wheat, hence the name windmill. Whilst a windmill uses rotational motion as a mechanical input, modern commercial wind turbines produce electricity by using said rotational energy to drive an electrical generator.
Within a wind turbine lies a drive shaft, a gearbox, and a generator, as well as an emergency rope and harness for the event of an emergency. When wind causes the rotor blades to spin, the drive shaft connected to it also spins and transfers the rotation to the gearbox, which converts a slow speed rotation 30 to 60 rpm of the blades into high speed rotation 1000 to 1800 rpm required for the generator to generate electricity. The generated electricity is then transferred down from the top of the turbine into the grid beneath. The largest turbines can produce 4.8 to 9.5 megawatts of power, have a rotor diameter that may extend more than 162 meters and are as tall as 240 meters. Meanwhile, the most common types of wind turbines, which produce up to 1.8 megawatts, are much smaller, having a blade length of approximately 40 meters and are attached to towers roughly 80 meters. The term of the area where multiple wind turbines are grouped together is called a wind farm, which provides a larger total energy source. Due to the need for wind to generate electricity, wind farms are very location dependent, and as such, wind resources are calculated based on the average wind speed and the distribution of wind speed values occurring within a particular area. Areas are grouped into wind power classes that range from 1 to 7. A wind power class of 3 or above, equivalent to a wind power density of 150 to 200 watts per square meter, or a mean wind speed of 5.1 to 5.6 meter per second, is suitable for utility-scale wind power generation, although some suitable sites may also be found in areas of classes 1 and 2. However, despite this geographical restriction, many countries have built wind farms. For example, the largest onshore wind farm in the world, the Gansu Wind Farm, has a capacity of 20 gigawatts with its 7,000 wind turbines. In addition, many other operational wind farms are in India and the USA, while the largest offshore wind farm is the Hornsea Wind Farm in the UK, which has a capacity of 1.228 gigawatts. By comparison, a typical new coal-fired power generating plant averaged about 0.55 gigawatts.
In 2023, wind energy contributes approximately 11% of the world's total electricity. Electricity generation by wind has been increasing dramatically because of concerns over the cost of petroleum and the effect of fossil fuel combustion on the climate and environment due to climate change. The wind power industry estimates that the world could feasibly generate nearly 20% of its total electricity from wind power by 2030. Various estimates put the cost of wind energy as low as 2 to 6 cents per kilowatt hour depending on the location. This is comparable to the cost of coal, natural gas, and other forms of fossil energy, which range between 5 and 16 cents per kilowatt hour. Challenges to the large-scale implementation of wind energy include requirements such as wind availability, aesthetic and environmental concerns, and land availability. Wind farms are most cost-effective in areas with consistent strong wind. However, these areas are not necessarily near large population centers. Thus, power lines and other components of electrical distribution system must have the capacity to transmit this electricity to consumers. In addition, since wind is an intermittent and inconsistent power source, storing power may be necessary.